Welcome to Sundar's lecture. This is actually lecture number 77, and in this lecture we are going to see RLC series circuit with Matlab, right? So before that, we try to see what are all the topics we have seen in the previous class. See, in the previous class we have taken a circuit for underdamped condition, and we have concluded that this is the voltage tabulation and this is the current tabulation, right? So we have substituted all the time values and we have concluded that the voltage is just oscillating above and below at a 10 volt, and then after some times it is reaching to 10 volt. That is what we have seen in the previous class, as well as the current waveform is also just oscillating above and below 0, and then it reaches to 0 after some times. This is what we have seen in the previous class for underdamped condition, and also we have seen for overdamped condition and critically damped condition. See, what we have seen in the overdamped condition, it takes long time to reach the 10 volt, but in the critically damped condition it takes less time to reach the 10 volt for voltage, and also for the current in overdamped condition it takes long time to get down to 0, and in the critically damped condition it takes less time to get down to 0. So this is what we have seen, and we have taken a numerical example with a pen and paper. We have solved so many things, solved differential equation, and then we have got the final expressions, and we have tried to substitute the time t is equal to some values 1 to 10 seconds, and then we have concluded, we have tabulated, and we have compared. So many things we have done in the previous 3 classes, but now it is very simple to understand this by the Matlabs, because you don't need to calculate anything, just give the values and then you try to learn what happens using the graphs, right? So what are all the R values? See, L and C we have taken it commonly. See, I will tell you just in a minute of time, in less time. See, what are all the L and C we have taken. L is equal to 1 Henry and C is equal to 0.05. That is common. We never change these two values. But for R we have changed, right? For overdamped we have taken 16 ohms, and for the critically damped we have taken 9 ohms, and then for the underdamped I think we have taken 2.5, right? We have taken 2.5, 16, 9, 2.5. That is what we have taken, and now we are going to just get into the Matlab. See, we have came to the Matlab. See, from the beginning I try to explain you. See, open the Matlab and go to Simulink, and you can see create model, blank model, and in that you just create a blank model here, and then you can see this one. See, this is the blank model, and you try to save this in any place, because even if you close it then there will be no issues. So I try to save it as RLC underscore series underscore, maybe for online classes, because I have already saved so many things. Classes for online class. Okay, then I have saved it. You try to save with your own name, but you don't give any spaces. If you give space, Matlab will not take it out. So this is the thing, and then what you do now, double click here, you can see a tab like this. You can double click on it, you can see a tab like this, and in that you get the RLC series branch. See, this is this one, you get that, it will be like this, and what you do, you just copy down this, paste it out, get another block, and then again you paste it out, get another block, and Control R. If you do that, you can see that it will be rotating. Then what you do, you go inside this, double tap on this, and then you can see branch type, you get it as R, and you give the value, and okay, fine, you just leave this, we will give the values after, and you can see that this will be converted to resistance. And again you double tap on this, we need L, only L, and then put and then OK. Click OK. Then you go to the third thing. We need C and then click OK. That's all, right? So now you can see that we have got three things. One is R, L and then C, right? Next what you do, again you double tap it, go for DC voltage. See, you can, if you type it, you will get this value. You can see this one, right? This is DC voltage and you keep it here. Now we have got everything, but what we need now, we need to measure the current and voltage, right? So what you do, again double tap or double click on the left side of the mouse, so you can see this block. And here what you do, you search for current measurement. See, it is coming here. Just type it out, you will get this one. Place it here, and you need voltage measurement. See, here it is, and then you keep this one now. Then what you do, you need to get into this one, right? So you have to connect this to here, and then you have to connect this to here, and then you have to measure it down, right? You have to measure current, and then you connect this one, and then you connect this value, this to this point. Now you have to measure the voltage. What is the voltage we are going to measure? Voltage across the capacitor, right? So what you do, you just take this point, come over here, put it out, that's all. And then again you take this one, come over here, put it here, that's all. Now what you do, see, we are going to see the graph, right? So what you do, double tap on this, get the go to tab. That is what we need here. Go to tab, click it out, bring it here, and then again you copy down this, copy and paste, you will get this one, and then you can get like this. So what you do, you just connect these two, and then you connect these two. So we have got two values now, two different values. Now go inside this, double tap on this, you have to change the value to I1 because we are going to create three circuits. So first what you do, create I1, go to tag value is I1 here. This is I1, circuit current number 1, and then go here, then put it as V1, voltage number 1, put OK, that's all. This is the circuit now. This is the circuit now. And here what you do, go inside, what is the voltage value we have taken? It is 10 volt, right? So you put 10 volt and give it as OK. Then you see this first, what is the first case? First case, what we have taken, it is over damped, and the second case is under critically damped, and the third case is under damped condition. This is actually over damped, critically damped is the second case, and third case is the under damped condition. So what you do, you go in, leave this, go inside the inductor, and you can see that it is L. You have to give the value here. We have taken 1 Henry, so give 1 here, and then set initial inductor current to be 0. We are not getting the any values. That is what we have assumed because I have 0 in the numerical problem, right? Then click OK. Then go here, capacitance. What is the value you are taking? It is 0.05 farad. And then you have to set the initial value to voltage. That is all. That's all. Now, what is the value we have given for the resistance in overdamped condition? It is 16 ohms. So I am giving it as 16 ohms. That's all. This is the first circuit that we have created now. And what you do now, you just copy it. Maybe you just double tap here, and then you give it as over damped condition. You just type it out, over damped, and then click OK. That's all. You can see the wordings here. You don't do anything, just type it out, click enter button, you will get a diagram like this. And we can copy this now, copy, and then you just place it out. You can see this, you put move the arrow marks, you can easily move this one like this, and you see this is not over damped right now, it will be critically damped, right? So you just change it to critically damped, right? So now we have to change these kind of things, right? This has to be I2 now, I2, because you cannot have a same tag. This has to be V2 now. I'm just taking it to be V2. That's all. and values I have to change it out. So how will you change the values for critically damped? See, this value is 10 volt, this is common. And what is the resistance value? We have taken it to be 9 ohms, right? So it will be 9 ohms, and then inductance and capacitance are same values. There is no change in the inductance and capacitance, so you don't need to do anything here. Then again I have already copied it, so I will paste it down. So I have to bring this one, just press the arrow marks to move up and down. If you are copying down, it will be very tough to drag, so you use the up arrow or down arrow or side arrow so that it will be easy. So now it will be under damped condition, so I'm just doing this one, under damping condition, and here you have to change this values, go to values, it is just I3, and then it will be V3, put OK. Then what is the value of resistance we have taken? Resistance has to be 2.5 ohms. That's all. Now we have done everything. We have just created the circuits for over damped, critically damped, and under damped. Now we need to get it. We need to show all the voltage and current values in the graph. So what you do for that? You go to, again, double click on any of the place, you will get a tool like this, or you get a block like this. So you just type it out, scope, you can see here, scope. Take that scope and you double click on this, double click on this, you go here and then go to file and then number of inputs. See what we have to see here, we are going to split this scope into two ways. So I am just getting it to two inputs because I am going to see voltage as well as current. Just close it down and then you click this one, you can enlarge this like this, you just enlarge it, and then what you do, you go for a mux here, mux, you can see a mux here, and then again what you do, you just click it down and you just enlarge it, double click on this. We have three inputs, right? Three currents are there, so I have just taken it three currents, and then what you do here, you just copy down this, paste it out. Again you can see this one. So three currents I am going to give here, three voltages I am going to give here. So for that what we need to do, you just again double click here, get the value, get a block from, see we have got the 2 here, that means this current is given to 2 here and we have to get from this point. So you just copy down this, we have 3 currents, so we have to go for 3 blocks like this. Anyhow, I need to change this, maybe I have to move this so that it will be easy. So it will be a second current and then paste it out, third current. That's all. Now you go here, double click on this, you just put a update tag and then you can see all the go to tabs here. So I need I1, just put OK and go to the second one. I need I2, just click OK and then go to the third one, double click on this, you can see I3 here, give OK. Then what you do, you just connect this one here, and then this one here. That's all. You just make it neatly. That's all. Again, you just copy down this, paste it out. We need 3 voltages, right? So for 3 voltages, again we have to paste it out. Again you have to paste it out, 3 voltages, and you just make adjustments. It will be easy. See, you go double click on this. This tag has to be V1 and then this tag has to be V2 and then this tag has to be V3. Give OK. That's all. You just connect this one, connect this one, connect this one. So what we have done now, we have just taken this current, give it over here. This current came here. This current came here. So this first mux will be a current mux, and the second mux will be voltage. What is V1? V1 is overdamped voltage. V2 is critically damped voltage. V3 is underdamped voltage. That's all. That is what we have done here. Then what you do, you just connect this one and then you just connect this one. That's all. Make it down. That's all. We have done everything. But for a easy understanding, what you do, go to this scope, double click on the scope, go to this one, the settings, click over here, and then you see, you just click layout, and then you just select these two. You can see a double column, double graph can be viewed on the same thing. You have to do this one, and again what you do, go to this settings and go to this style, click OK, and then you can see active displays. Two displays will be there, and I am going to use, this is display number 1, this is display number 2. Be very careful to understand this one, because it will be very difficult to understand. Anyhow, you just see this one, right? So what we have to do here, this figure color, you just change it to white and then you apply, or it may be leave this one as it is, and then what you do, axis color, it will be like this. So what you do, you just go to the settings and then you go to this one. See this color, you make it to white, and this one you make it to white, and then this one you make it to white. You will get white background, right? Now this will be there. This channel, if it is active display is 1, then this is the first display and this is the second display. What you do, you go to the active display 1, channel number 1. Channel number 1 means it is current, and in the second active display it will be voltage. So you go to this one, make this color to, I am just going to give it as red, and then this value as 1.5, and then make it apply, and go to channel number 2, and this one has to be 1.5. Just it is the line diameter, line thickness maybe. This is R. I will give it as Y, and then apply, and then go to channel number 3, make it as 1.5, and RYB, I am just taking B, blue color, apply. See what I am just doing in channel number 1, that is in the first display, current display, first channel, that is current in the underdamped, overdamped will come in red color, and channel number 2, that is critically damped, and that will be yellow color, and channel number 3, that is nothing but it is the underdamped condition current, will come in blue color. That's all. That is what I have given here. Go to display number 2. Now if it is display number 2, it will be this one, and for channel number 1, this is voltage, and I am giving the same color, 1.5, and this will be now R, red color, and then channel number 2, it is also 1.5. I will give it as RY, yellow color, apply. Channel number 3, give it as 1.5, it will be B, blue color, apply. That's all. Give OK. Now you see, this is the graph, and this graph will give you current, and this graph will give you voltage. And what is the first thing I am having? Where is it? RLC, right? So this is overdamped condition current, and this is the underdamped condition, sorry, critically damped, and this is the underdamped condition, right? So now you see, now I am going to give power GUI. So you go here, type power GUI, you can see a component like this. It shows that it is continuous, and you double tap on this, go to this one, make it as discrete, and make this value to 1 e power minus 6. So click OK, then you can see a block like this, right? That's all. So we have done everything, converted this to discrete, and 1 e power minus 0.6 seconds. And now what we are going to do, we are just going to run this program. This is overdamped, this is critically damped, this is underdamped, right? So run it out, and it will be running like this. It will take 10 seconds, maybe around 10 seconds. Let us wait for that. and then we will go to the scope so that it will be easy to understand. As it is just running, it's keep on running. Wait till that, because the graph will be now, it is getting down in the scope. Anyhow, we try to wait for that. Wait till it reaches 100%, and then you see it will be very interesting what happens to current and voltage in RLC series circuit. That's all. It is done now. What you do, you just double click on the scope. It will be coming. Double click on the scope. That's all, right? You see here, we have just got the graph here, and see this one, maybe we can change this. This R, I have taken it to be current, right? Over damped current, so it will be over damped current. Maybe I put it as I, over damped current. That's all. And then this value, it is critically damped current, and then this value, it is under damped current. That's all. Now you see this value, this is nothing but over damped voltage. You can change this because it will be very easy to understand. That is why I am doing this. And then this is critically damped voltage, and then this value, it is under damped voltage, right? Under damped V. That's all. Now you click this. See, first I will see over damped current. See, over damped current, it reaches to 0.5 and then it is coming down to 0. Current will become 0, right? Current will become 0, and then I am going for over damped voltage. See, over damped voltage, what it is doing? This is 1 second, 2 seconds. It all seconds. You come here, this value, I am just taking it to 10 seconds. See here, it is 10 seconds. I am just taking it to be 10 seconds, right? So now what you do, you see, you compare, this one is going to 0.5 amperes and then it is coming down to 0. This is the over damped condition, both current and voltage. And I am just going for critically damped current. See what happens in the critically damped current, it is going to 0.7, but it gets to 0 here itself. In this point, it becomes 0, but you see, over damped is going to get it is getting to 0 at this point, maybe around 2.5 seconds, but this critically damped current, it is getting 0 at 1.5 seconds itself. And then you see, I'm just going for critically damped voltage. See here, it takes around 3 seconds to reach 10 volt. This is the 10 volt, but at a critically damped condition, it takes around only 1.5 seconds. 1.5 seconds to reach the 10 volt condition. That is what, that is the comparison we have seen in our maybe pen and paper. We have solved the example with the pen and paper, and we have concluded that at a critically damped condition, the current becomes 0 very fastly. Critically damped condition, see, current becomes 0, but here at over damped condition, the current, it takes long time to get to 0. But at the other hand, the voltage here, it is getting to 10 volt around 3 seconds, but here it is 1.5 seconds. And then you go for under damped condition. This is very interesting. See, under damped condition, what is happening? It is going to 1.5 and coming to minus 0.6, and again it is just increasing, oscillating, and it is getting to 0 maybe around 5 seconds. But it is oscillating. That is what we have seen. At under damped condition, the roots will be complex conjugate, And if you substitute the t values, then the current will oscillate over 0 and comes under 0. That means going to negative and then coming to see here, it is going above 0, below 0, above 0, below 0, and then it is settling down to 0 current, right? At the same time, you go for the voltage. See here what is happening. It is going to 14 volt. Just we have seen this one, right? The same value around 14 volt at this particular time. That is what we have seen at 0.75. I think you just refer my previous lecture. You can easily see what happens with the pen and paper. We have solved this example with the pen and paper. It is going to 14 volt and coming down below to 10 volt here. See here, it is around 8 volt, right? It is coming down to 8 volt and then it is increasing above 10 volt. See, this is the 10 volt line. This is the 10 volt line. It is getting above 10 volt and then again coming down to below 10 and then increasing to above 10 and then it is settling to 10 volt around 4.1 or to 4.2 seconds. And see, these are all the three conditions. Red indicates the overdamped condition and the yellow indicates the critically damped condition and blue indicates the underdamped condition. This is current waveform and this is the voltage waveform. This is what we have just solved with the pen and paper. But you see, this is very clearly, right, the technology has improved and even if you are simplifying it with pen and paper, you cannot see a clear view of graph with the pen and paper. It is very tough to do with pen and paper. Anyhow, we have just done with the Matlab, and you go through this Matlab. If you have any doubts in this particular lecture, please feel free to ask any doubts. If you want anything, if you are not understanding anything, please put it on the comment box. I will reply it, right? So go through this and we will see a new topic in the next class. Thank you.